Okay, Chapter 9 review. State if the three sides form an acute, obtuse, or right triangle. So for these, you need to know if the hypotenuse squared is greater than, equal to, or less than the a squared plus b squared. So we need to find the a squared plus the b squared for each of these and the c squared. C is always the biggest number. So we should say 13 squared, 6 squared, plus 12 squared. And then we do all those calculations and make sure that we know which one's bigger or if it's smaller or equal to. So 13 squared is 169, 6 squared is 36, 12 squared is 144. So you have 169, 36 plus 144 is 180. So 169 is going to be less than. Less than means acute. Okay? Go to the next one, do the exact same thing. 15 squared and then 9 squared plus 11 squared. 225, 81. What's 11 squared? What? Okay, I was just waiting. So 121 and 81 is 202. So 225 is bigger. Greater than means obtuse. And if it was an equal sign, then we'd know it's right. All right. Pythagorean theorem again. Find the missing side length. So identify your hypotenuse. There's my hypotenuse. So we have 12 squared equals x squared plus 8 squared. And now we just solve for x. 144. And we subtract the 64. So that's 80 equals x squared. And then you take the square root. Leave your answers in simplest radical form. Simplest and exact means do not touch your calculator. So you need to break down the 80. So that's 16 times 5. You could have done 2 and 40 and kept going from there. I choose to try to find which perfect squares will work, and that makes everything a lot easier. So x is equal to 4 square root of 5. So just on a side note here, 2, 3, 4, 5, 6, 7, 8, and you just can keep going. That's 4, if we square them, that's 4, 9, 16, 25, 36, 49, 64, and you can keep going from there. So when I see something like the square root of 80, I'll take 80 on my calculator and I'll divide it by 4. That'll work. All right, I could have said square root of 4 and 20, and that's a 2, but then 20 would be 4 and 5. That's 2, and that's 5. So we get 4 square root of 5 again. You can do it that way. But I tried to figure out the biggest perfect square that'll work, and 16 was it. 16 times 5. If I take 80 divided by 16 on the calculator, I get 5. So I know that the square root of 80 breaks down into those two numbers. And I know the square root of 16. So it's just a quicker way of doing those trees. So that's on you guys. If you want to do that, feel free. All right, same thing here. So identify your hypotenuse. 15 squared equals x squared plus 6 squared. 225 equals x squared plus 36. Subtract the 36. What's 225 minus 36? 189. You take the square root of both sides, and that's 17. No, it's not 17. Is it? So, what is it? Okay, so what's 1 plus 8? It's not even, right? It's not even, so 2 won't go into it. Add the digits. 1 plus 8 is 9. 9 plus 9 is 18. Will 3 go into 18? So 3 goes into 189. What about 9? Does 9 go into 18? Yes, it does. So I know that 9 will go into it. Again, you could do the last thing. You could go through all those processes. 4 won't go into it because 89 is not divisible by 4. That's the pattern for using 4. 5 won't go into it because it's not a 0 or a 5. 6 won't go into it. You need a 2 and a 3 for 6 to work. So then that brings me up to 9. And you could keep going after that. You could try 16, then 25, then 36, and see if you got a bigger one. So let's just do this. 9 goes into 189 21 times. That's 3, and that's the square root of 3 and the square root of 7, which those aren't perfect squares. So your answer should be 3 square root of 21. Who got that right? All right, good. So now, special right triangles. Use the special right triangle rules. All right, so now let's write, we have 30, 60, 90 here. So we have the hypotenuse equals twice the short leg. And what's the long leg? Times the square root of 3, right? Okay, so now we plug everything in. What's the hypotenuse? Again, always knowing your hypotenuse. 6 square root of 3 equals 2 times the short leg, which is v. Please make your v's and u's different. Make it obvious. Divide by 2. That reduces to 1v. And the 6 and the 2 reduce to 3. And that's your v. Now the long leg is u. The short leg is v, which we just found, 3 square root of 3. And we multiply that by the square root of 3. There you have a pair. So u is equal to 3 times 3. So u is 9. So now we have 45, 45. So what's the formula for that? All right. So hypotenuse again, identify it. That's x. The short leg, or excuse me, the leg, that's what this is really. Not a short leg or long leg. So that's, you should have already said y is equal to 4 square root of 2, because in a 45, your legs are the same. So now your leg is 4 square root of 2 times the square root of 2. And that's a pair again. So 4 times 2 is 8. There we go. All right, 7. Again, 45, 45. These two are the same, but that doesn't help you because they're both variables. Hypotenuse equals the leg times the square root of 2. So the hypotenuse again is 10. And your leg is x or y, they're the same. So we divide off the square root of 2. So now you have to rationalize your denominator by multiplying by the radical. That's 10 square root of 2. And there's a pair. So the square root of 2 times the square root of 2 is the square root of 4, which is 2. And then the 10 and the 2 reduce. So your answer for x and y is 5 square root of 2. I don't know what's going on with my pen today. All right, number 8. 30, 60, 90. So let's put everything out here. Hypotenuse, again, is equal to the short leg times 2, or twice the short leg. Your long leg is your short leg times the square root of 3. Hypotenuse is A. The short leg is B. So that doesn't help us yet. Long leg is 9 square root of 3. Short leg is B times the square root of 3. So here we're just substituting everything. Divide off the square root of 3. Those reduce out to 1s, so 9 equals B. and we substitute that in. A equals 9 times 2, so A is 18. Number 9, use trig to find the missing side length. Round to the nearest tenth. Side lengths are to the tenths. So what corner are we at? At 64. This is my hypotenuse, this is the adjacent leg, and that's the opposite leg. So we are using those two pieces, opposite and adjacent. That's tangent. So the tangent of 64 is equal to the opposite leg over the adjacent leg, x. Got to get x out of the denominator, so we multiply by it. And then we divide by the tangent of 64. Okay, so the 12 divided by the tangent of 64, round to the nearest tenths. Okay, so that's going to make that 5.9. All right, 10, the same type of thing. Starting at this corner, we have the opposite leg, that's your hypotenuse, this is adjacent. So we have the tangent again of 61 is equal to the opposite leg over the adjacent leg. Multiply by 17 to get x by itself. So x is equal to 17 times the tangent of 61. And we are going to round the side lengths again to the nearest tenth, 30.6688. So we get 30.7. So everybody should be getting the exact same answers on your test. All right, so let's go to the second page. Let's put this on here. Take a screenshot of this if you're watching and you want to see the whole thing. And now let's go on to the next page. All right. Number 11. Still using trig functions. Here's our corner. Whoops. There's our corner. There's our hypotenuse, and there is our opposite leg. So that would be the sine function, SohCahToa. Sine of 41 is equal to the opposite leg over the hypotenuse. Multiply by 16 to remove it. And take 16 times the sine of 41. And you get 10.4969. So that should be rounded to the tenths. Makes that 10.5. All right, number 12. There's the corner. That's our hypotenuse. That's our adjacent leg. That's cosine. Cosine of 21 is equal to the adjacent leg x over the hypotenuse 12. So multiply by 12. And x is equal to 12 times the cosine of 21. 11.202965. So 11.2 is your answer. Now we're finding the degree. So we're going to work the trig function backwards. Here's our corner. That's the hypotenuse, that's the opposite leg, and that's the adjacent leg. So these are the pieces we've been given. That's tangent. So the tangent of your angle is equal to the opposite leg over the adjacent leg. So the measure of the angle is equal to the arctangent of 109 divided by 42. So arctangent, second tangent, is 109 divided by 42. It said nearest degree. This says measure of the angle is 68.92727. So we look at the tenths position, and that's going to round that up to 69 degrees. That's your answer. Number 14. That's our corner. So our hypotenuse, the adjacent side. So we're going to be using cosine. So the cosine of the angle is equal to the adjacent leg over the hypotenuse. So the measure of the angle is equal to the arc cosine of 14 divided by 23. And so we get 52.50475. And we went to the nearest degree, so that's going to be 53 degrees. And now we have a couple story problems. You go to the park on a windy day to fly a kite. You've released 50 feet of string. The string makes an angle of 32 degrees with the ground. How far away are you from the spot directly below the kite? So that's our corner. We have our hypotenuse and the adjacent side, so we're using cosine of 32 degrees is equal to the adjacent over hypotenuse. And that's how you set these problems up. Draw a picture. Multiply by 50, and you get your x. 50 times the cosine of 32. We'll round to the tenths again. This is 42.4. And that's feet. You're 42.4 feet away from underneath the kite. Same thing with 16. We're drawing a ladder against the side of a building. So the bottom of the ladder is 3 feet from the building, and it goes up 10 feet on the side of the building. Find the measure of the angle that it makes with the ground. Round your answer to the nearest degree. Okay, so we have our hypotenuse, our adjacent side, and we have our opposite side. So we're using tangent. So the tangent of the angle is equal to 10 over 3, opposite over adjacent. So the measure of the angle is the arc tangent of 10 divided by 3. So second tangent, 10 divided by 3. And we get 73 degrees as our answer. So always draw a picture if you can in a story problem. Usually shows you what you've been doing in that section. So find all the missing sides and angles of everything. So the last two are what we've been working on. So what's first? That's the corner. We have the opposite side and the adjacent side. So we're going to start with tangent of 21 is equal to the opposite leg over the adjacent leg. The variable is in your denominator, so let's multiply to get it out. And then we'll divide by the tangent of 21 to get x by itself. So 15 divided by the tangent of 21 gives me 39.1 if you round to the tenths. And now we need to get the hypotenuse. So we'll use the opposite leg and hypotenuse. So that's the sine of 21 is opposite over hypotenuse. Again, it's in the denominator, so you got to multiply by it. So then you're going to be dividing by the trig function. So 15 divided by the sine of 21 gives me the hypotenuse to be 41.9. Okay? And then to get the angle, the measure of the angle is 90 minus the 21. So that's 69 degrees. So this is what you should circle, what should make it easy for me to see what you have. Your work should be over here. Okay? Let's do number 18. So this is the corner we're at. This is our hypotenuse, adjacent, and opposite. So we've been given the hypotenuse and the opposite leg, so that's sine of a degree, we don't know. The opposite leg is 28. The hypotenuse is 34. So to get the measure of the angle, we take the arc sine of 28 divided by 34. So second sine, 28 divided by 34. And we get the measure of the angle to be, to the nearest degree, is 55 degrees. All right. So now, the other angle, so you can label them if you want. So the other angle is going to be 90 minus the 55, which is 35 degrees. And then now we need A. So we can use the Pythagorean theorem or trig. I would suggest using the trig because you're going to round to the tenths, and you could use your square roots and stuff in the Pythagorean theorem. I'm going to do it both ways to show you. Most of the time it's going to be very, very close, if not the exact same rounded answer. So the trig function, to get A, I'll use the 55, which has been rounded. Okay? And I'll use the adjacent leg and the hypotenuse. So that's cosine of 55 is equal to the adjacent leg over the hypotenuse. So multiply by 34. So 34 times the cosine of 55 gives me 19.5. If we use the Pythagorean theorem, 34 squared equals a squared plus 28 squared. 34 squared is 1156. 28 squared is 784. Subtract that from 1156, and we get 372. And since we're rounding, you don't need to break that down. What do you get when you take the square root? Lots of steps when we're doing the Pythagorean theorem. I get 19.287, so 19.3. The 19.3 is more accurate because we didn't round until the end. 55 was rounded. We used that. And then we rounded the answer at the end. So I will take either of those answers on the test. You got to be fairly close. Okay? Are there any questions? If anybody needs a screenshot when they're watching this, there it is. And that'll be it for the review. Good luck.